So my name is Ricardo. I'm working in the international team of AHP for 8 years now, and we are 5 people working all around the world to take the name of AHP to the 4 corners of the world. AHP is located in Germany. Gottenheim, this is the southwest of Gottenheim, southwest of Germany, and it is close by to France and Switzerland. At the moment, we are 250 employees, and we have daily production of 450 cylinders. The seminar that we will present today is the advantages regards our block cylinders to the tie rod. Tie rod cylinders are very much used in the North America. This we see a lot. The last 2 weeks I was in Mexico traveling around and making some presentations also, and many tools that I saw from Canada and from the US come with tie rods. It's amazing to see also the difference, because from the tools that I saw from Europe and from China, China, I'm not saying the big majority, but some of them already have this concept of a block cylinder. So we will try to explain the differences between using a block cylinder and a tie rod. So we have here a tie rod that is a 50 millimeter bore, 36 millimeter shaft, and a 200 millimeter stroke. What bonds the inner tube together with the end and the front and rear cap is the tie rods. That is why it's called a tie rod cylinder. So this would be the structure of the tie rod and how it is assembled with this inner tube that we can see here. So what in end effect is happening is that we are tightening a tube between 2 parts by the means of this tie rod. So if we go a little bit more in detail, what is sustaining the pressure of the hydraulic is, of course, the tie rods. And we can see here, and I can make it a little bit bigger, that the surface area of the tie rod in this case is 112 millimeters per tie rod. What would mean a total of 450 square millimeters per the 4 tie rods together. If we would see our block cylinder, so this is one of our block cylinders that we compare exactly the same bore, exactly the same shaft, and also the 200 millimeters of stroke, we can see just by the block that we see here, it is much more robust, and it's a unique part. So we are not compressing any tube, we are not using any kind of rods, it's just the complete block itself. So here we made a section also for us to see the difference between the surface of metal that we have. So by making the section, we have 5,539 square millimeters. This means that we have 12 times more area than the 4 tie rods together. So I don't think this needs much more introduction or much more explanation. We can see perfectly that it is more robust than the tie rods. So coming back once more, we have 450 square millimeters against 5,540 square millimeters. These are some photos that I took last week, where we can see a tool here that is using a tie rod cylinder. It is quite often that I saw this application where we needed to tie a tie rod to a plate when we have the parting line, as you can see here. So this would be the parting line when the tool is opening. All this area that we have here is in the air, let's say, and when there is pressure moving the ejector plates back and forward, they will bend. When they are bending, this is when the problems start, and when we start to have leakages from the seals. The bending of the cylinder because of the tie rods, because of the pressure, then will damage the seals. So here I took the opportunity also to show some, to get some more pictures of another tools that where we can see the external plumbing. So there is a lot of plumbing made that also is an extra work, but in transportation, all this plumbing also can get damaged. This was one thing that I had some complaints about, that the tools when they were coming from wherever, because of the transports, the plumbing would be sometimes damaged. So as you can see here, many different examples. I'm just coming back again for you to have the possibility to see it again. And the tie rod mainly, or the only way to feed tie rods is with external plumbing. So our proposal with our block cylinders is a very neat, in my opinion, construction of the tool. So we don't have any kind of external plumbing. As you can see here, also we have the parting line here with the tool open, but the block cylinder is attached to the core plate, and we don't have to do any additional plates to be able to fix or to assemble the cylinder. Here we have some more examples. The only thing that we can see here is the plumbing of water, and not any kind of plumbing of the hydraulic circuits. So just some more pictures that can show perfectly how neat it is regards the oil. I can say with this video that we also had some issues regards the length of our cylinders when it came up to being used in the parting line. So we have to do this additional plate as the ones that I showed earlier, but it's not with the internal plumbing. So we developed a cylinder that we call it our system port cylinder, where we can move or replace the inlets and outlets of the oil. So we are flexible on this. It's customized. You can put wherever you would like the inlet and outlet, and this way we can avoid the intermediate plate, and we can feed our cylinder through the mold base itself. Okay. Here is also a very nice example of a cylinder, a small block cylinder. The tie rods tend to be larger than a block cylinder. So here in the middle, we have a small block cylinder to actuate an internal mechanical mechanism that this tool has. And I would like to show you the difference in size regards the same stroke that we have here, that it's a 50 millimeter stroke, that we have a total of 115 millimeters. But if it would be to have the same stroke with a tie rod, you would have 209 millimeters. So our solution is more compact and easier to build in the tool, and it saves quite some space. So I would like to show you also our cut configurator, where I can show the differences. We also have a box cylinder. Using the blocks, tie rod, and that's why we add to our catalog. This always also allowed us to come into some customers and gave us the opportunity to explain to them what is the differences between the block cylinder and the tie rod cylinder. And fortunately, this opened us some business opportunities so we could start selling our block cylinders. So here we have exactly the same mounting mode as we could see here. Let's put a little bit of stroke here. Let's say 200 millimeters. Let's say here also 200 millimeters. This cut configurator is available in our website, so you can go directly to our website and you can configure your cylinder online, and then we can also send the 2D and 3D files in nearly any format that you would need. So here we have our block cylinder versus the tie rod. Normally, what is used in mold making would be this kind of mounting mode, where we put the screws in the front flange, and this would be ours. Here you can see that we have the external ports. Here we also have the external ports, but to avoid external ports and plumbing, we have our mounting modes here that you can see with an O-ring. This is a mounting mode that we have the O-rings from in the beginning and on the end of the stroke, but as shown in our video, it's possible to deplace the inlet and outlet of the ports. So we also can change this, and as said, it is possible to do customized measures. This is, of course, not possible to do in a tie rod cylinder. Okay. One additional advantage that we have is that it is possible to add sensors. For example, here we have sensors, inductive sensors. We can have also mechanical sensors. that we can change even the side of it if it's needed. And we have also, we call this our MBZ, that it is an aluminum body with magnetic sensors. Here we can read, or we can set the reading of the sensors, the switches, wherever we would like in this rail. For example, in the tie rods, this is not possible to put sensing. I have seen some inductive sensors they are connected to the tie rods here, but they have quite some failures. This is why at AHP we do not have sensors in our tie rods, because it's not 100% guaranteed that it is reading correctly. In our block cylinders, this doesn't happen. So other than the robustness that we have in our block cylinders, we also have several sensing sensors possible, as said, inductive, mechanical, or magnetic sensors. Other than that, maybe I can put it a little bit bigger. We could see here that we have several kinds of mounting modes. We can have, for example, inlets and outlets from the front side of the cylinder. When we say the front side, there is the piston. We also have from the rear side if it's needed. And once more from underneath, always with our O-ring concept. Of course, we also have with external plumbing. Once more, this side we can put also the connections in the larger surface of the cylinder, as we also can put on the lateral side of the cylinder. So once more, to say this information is available online, or you can download our CAD catalog from our website, and where you can find all this information. We have, as you can see here, the CAD formats that you would like to download it in the 3D or also in 2D. Okay. So I don't know if any of you have some questions. I still don't know if you're hearing me correctly or not.
Yeah, Ricardo, we could hear you. It's a little choppy, but we're doing well. But we do have a question right now. It says, how are lead times affected when making changes to standard cylinder O-ring placements?
It's all our, if it's a standard block or a standard stroke, it's a matter of 5 additional working days. Okay, so for example, if we have what we call our quick delivery program. If the strokes are, for example, 10 and 10 millimeters, so if you choose one of these, we can have it in stock, or it can be made up to maximum 12 days, 12 working days. If it is, for example, 15 millimeters that we don't have, so this can take up to 17 working days. But we still think it's quite quick. What is important, and what we try to inform our customers, is that, for example, if you see here, when I select a 100 millimeter, it says selected stroke is quick delivery program. So this is the quickest and also the cheapest. If I select 105, it says selected stroke is special. Okay, so this is important, so you can know what is standard and what is special. So let's go to 110, and as you can see, selected stroke is quick delivery program again, meaning that this will be maximum 7 working days we can have our cylinder.
Okay, great. We have another question here. If I have a piston in my mold, is it possible to download the CAD only with the part number?
With the part number, it is not. This is not because the part number is like the ID of our cylinders. It's a six-digit number. We need to have the reference part. The ID, well, the reference part, it is made for us at AHP to detect it 100%, because this was made regards to specials, that we only have an S at the end of the reference, and we need to know exactly what is the part. So no, it's not possible to have only with the item number.
Okay. Another question we have here is, what are the recommended spare parts for a cylinder? And is it possible to download a boom list?
Yes, it is possible to download a boom, well, I call it a bomb list. When you download the PDF file, you will have the spare part of the piston, you will have the spare part of the seal, and you will have the spare part of this bushing here. So you will have all the spare parts on the boom list. Or even the other way around, if you're looking for what spare part it is, you can come to our CAD configurator, you configure what the cylinder, and you can find immediately the spare part.
All right, perfect. If anybody has any other questions, please, we invite you to put them in the chat or in the questions box on there.
Well, I would like, I have a question for if somebody would like to answer me this. While traveling through the US and while through Mexico, and why is the concept of a tie rod, when we see that it's complex, that it has so much plumbing to do, and why does the North America use this kind of concept against a block cylinder? I'm not saying a block cylinder of AHP Merkle, any kind of block cylinder, because a block cylinder, in our opinion, it's a more stable part because it's more robust. This is no doubt. What we showed, it's 12 times more robust than a tie rod. And also all the different mounting modes and also sensing possibilities that we have. And still, it is used more in the US and in Canada, the tie rod. This I would like to understand the concept. Why is it like so? Is it a traditional thing, or why is it used so much in the US?
If anybody has an answer of why they're using the tie rods instead of blocks cylinders, please put it in the chat on there. I mean, obviously, the block cylinders are stronger, and it's, that's one of the benefits of using the AHP Merkle.
Hey, Ricardo.
Yeah, because also the additional work that there is in plumbing. Okay, if you choose for a block cylinder that you have external plumbing, you have to do it at the same time. But I can say in Europe, it's very common to see the plumbing being done in the mold base itself. So it's easier to assemble. There is doesn't occupy so many space, and also it doesn't tend to break the connectors, and it's cleaner, let's say. And this is something that, as a European mold maker, I cannot get an answer to it. And when I was in the US traveling with a DME salesman, this is something that I always asked, and the answer was, it's tradition. We always made it like that. And they really understand the concept of the block cylinder, but the issue is we did it always like that. Maybe this is the answer. I don't know.
Hey, Ricardo, can you hear me?
So Ricardo, can you hear Dave talking or no?
No, I cannot.
Okay.
Sorry.
Well, I guess being a mold maker for 40 years, I can attest to, I believe it is a tradition thing, only because that's what was offered in the past mainly. I'm not going to lie, myself, this is the first time that I saw a block cylinder when I joined DME. Before that, it was, the local businesses sold tie rod cylinders. It was like really your only choice. So that's just my input on that.
So yeah, basically, is Ricardo, you said was yeah, it's basically tradition. It's like what you said. It's just yeah,
Okay.
it's what everybody always used before. We
Okay.
have some more questions in on here, and Dave, you might be able to answer this one, or Ricardo. What is the average lead time to the USA if they order something from AHP Merkle?
So the average lead time, let's say for our standard, as said once more, our quick delivery program, maximum it is 12 working days. Okay. Everything that goes out of this can go to 17, or specials, it can go up to 20, 23 working days. But okay, let's put this apart, that because we have quite a big offer in dimensions, in strokes, okay? So I would say it would be the 12 working days plus the shipment. We are sending out today weekly shipments to the US that it takes 1 week to get to the US, and then it's the internal shipment from Detroit to wherever. So this would mean maximum 12, plus 5 is 17, plus some additional days. In the worst of cases, let's say it would be 4 weeks. But if we choose a stock cylinder that is on stock, for example, this is one thing that I don't know if the US customers know, but DME has a quite nice stock of cylinders that they are pre-prepared with, I can show you, with this concept of sensing, of sensors. We call it our BZP, that it's inductive switchers that are inside this this part here, and it's adjustable on the end stroke 8 millimeters per side, meaning the C16. So DME has on stock pre-prepared housings that they already have these 4 drilled holes that the customer then can choose with or without sensing. So this is available on stock in Detroit. Everything that comes from Germany, if it is in our quick delivery program, it will be 7 working days. So this would mean maximum 3 weeks, 15 working days. The customer could have his part at his company.
Perfect. Yes, we do have the standard cylinders in stock at DME.
Yeah, That's it.
Other question
So
we have here is, what is the maximum operating temperature that the block cylinders can accommodate?
well, this can go up to 700 degrees, I think. This is the block cylinder, the block itself. But of course, we have to check it's the seals. So we have two type of seals. We have the MBR seals that can go up to 120 degrees. Over the 120 degrees, we have Viton seals. The Viton seals can go to up to 180 degrees. Okay, so this would be the maximum temperature that our cylinders can work with Viton seals. Over that, we recommend to have a cooled cylinder that we also do have in our catalog. This is a special cylinder. What we do, we cool the cylinder with water. We have a jacket inside that is cooled by water. Then we can go to higher temperatures. But let's say as a standard, maximum we can work up to is 180 degrees.
Great. What are the pressure ratings in comparison to tie rod cylinders?
Okay. We have the test that we made with the tie rods. We recommend our customers only to go up to 160 bar. We know that Parker points out that they can go up to 210 bar. To be very honest, the tests that we made, this is quite difficult, because we have to take in mind that a short stroke, for example, 50 millimeters is one thing, that the tie rods are smaller, the part is smaller, and they can withstand more pressure. But if you have, for example, a cylinder that has 300 or 400 millimeters, this is a completely different story. So that is why we go down to 160 bar. This is what we recommend, and we see it difficult in larger strokes that a tie rod can sustain 210 bar. We, in our cylinders, if you can see here, maybe it's a little bit small, but this tie rod, this block cylinder, sorry, that has 110 millimeter, can withstand up to 320 bar. Why 320 bar? Because it has this pocket here, because it's bigger than 100 millimeters, and when we do the milling throughout the block. If it would be under 100 millimeters or even 100 millimeters, if you can see here, it is a closed block, and you can see here that it goes up to 500 bar. So our cylinders, our box cylinders, they have three different kinds of capacities. 500 bar, where it has no rear cap. When it has the rear cap, as you can see here, if I change this to 150, it goes down to 320. But if I change this to a mounting mode that we call the mounting mode 31 that I showed you on the videos, okay, this goes down to 250. Why? You don't see here, but to make these circuits, we have to make some circuits here, and then we have to close them pressure fitted. And that's why we only go up to 250 bar. But nevertheless, it is more than the 210 bar that Parker recommends, or Parker says that they can achieve. I hope I could make myself understandable.
Yes, you did. Thank you. The last question we have right now is, I believe this is talking about lead time, but is the lead time the same for Canada? And I would say just yes, it would be the same time, give or take a few days, just to get across international lines. But yes, we can ship from Madison Heights and over to Canada as well. Does anybody have any other questions on here? We still have about 15 minutes left in our time on here. And Ricardo, I'm not sure if you wanted to go over that one other presentation you had real quick. I don't know if there's
Yeah, sure. There is, so I can go quickly through this one also. So here, what we also have is where we compare.
There you go. Thank you.
Yeah. So here we are comparing our what we call HZ cylinder. It's a tube cylinder. Okay. The tube cylinder doesn't have so many mounting modes. It's not possible also to put so many different sensors, but it's comparing once more the tie rod to a tube cylinder. What we have here, and I can say that the founder of AHP, Mr. Gerard Merkle, when he started the company, he didn't believe in the tie rods. So he developed what we call today our AHP standard cylinder. That is our HZ. It's a tube that also a tie rod has, but instead of having the tie rods, we thread the front and the rear part, so it has a bigger connection between the tube and the front and rear part. So this is the difference that you can see, where we have here only the tie rods, and the difference between having a 6 or 8 millimeter thick tube with a screw working between two caps. So what happens here, this is an example that when we have the tie rods, there is a tension. So what happens, there will be the tube gets, the tie rods get longer, and that's why we have then also leakages, because the threads tend to get longer and they are not closing the tie rod, on this case the tube, together. Okay, so also we can see regards dimensions once more. Our solution for a tube cylinder is smaller than a tie rod, only for you to see and compare. Now, this is a formula. What happens here is that we have on this red points here, it's an O-ring, okay, that is once more it is together, well, it's compressed together when the tie rods are fixed in the front and the rear part, and here we are screwing both rear and front part to the tube. This is more for machine making, but here you can see that we have a turning that it can rotate upon itself. I also can show you quickly on our CAD configurator the option of our AHP standard. So we have also 250, 160, and 100 bar. Once more, we don't go up to the 500 bar as we have on our block cylinders. So we could recommend, for example, this would be the most similar to a tie rod. So here we only have possibilities of inductive sensors. It's not possible to put mechanic. It's not possible to put magnetic. So that's why the block cylinders have more options. Here we have the external feeding only, of course. If we don't want to have it lateral, we can take this out. We also have different kinds of standard parts that we can use, because these tube cylinders, they were developed for machine building more at that time, 50 years ago, when Mr. Merkle started with the company. So it's also possible to change only this oil port to the rear side, nothing more. And one big advantage of this kind of cylinder is that we can make 2 meter long cylinders. As said, this is why it was more used in machine building. So we have some customers like Crossmafai, we have some customers like Engel that are using our cylinders in their machines. So if we talk about robustness, block cylinders are the most robust. Secondly, it would be what our proposal is about our standard AHP cylinder that we call the HZ. And then last of all, it would be the tie rod. So just to make a small resume, is block cylinders have many different kind of mounting modes. It is possible to feed from the mold base itself, that in our opinion, it's a cleaner job. It's also protecting any kind of connections. Then it would be this proposal that we call it our tube cylinder, that only has the possibility of inductive sensors. And then third of all, it would be the tie rod. But as I said, the tie rod, we have it as an obligation, let's say, to serve some customers that use us already and prefer tie rods in die casting, or other customers that we want to try to get in and convince them about using our tie rod or even our tube cylinder.
Awesome.
Any questions?
Yeah, if anybody has any additional questions, yeah, please put them in the chat. We do have one additional question right now, Ricardo. Question is, what is the biggest difference between plastic cylinders and die casting?
Okay, so both of them can be used both in die casting and in plastic mold making. Okay, for example, we at AHP do something that many other producers don't do. Our piston rod, it's hardened, always hardened. Okay, many producers, they don't have it hardened, it's only chromed. But we do this so we can cover the whole scope of die casting and plastic. Die casting is a very dirty environment. They have a lot of metal chips always on the tools because of the aluminum. And for this, you need to have hardened steel and stronger steel, let's say. So we don't make a difference between where it's going. All our cylinders have hardened pistons, and this is a very big advantage when it's being used in die casting. For maybe plastic injection mold, it's not necessary to have a hardened piston. but having a hardened piston will assure that you will never have scratches on the piston that then will also damage your seals. So we have to take in mind that die casting is a rough environment, very aggressive, a lot of oil, a lot of even aluminium that is poured on the cylinders that I also had the opportunity to see many, and the having this hardened the piston and also the steel grade of the hydraulic itself helps a lot in this in these environments.
Great, thank you. That one. Are there any additional questions that the group might have? We have about 10 minutes left, but what we'll do is, while we're waiting for the last questions to come in, to let you know, we will be sending out this presentation out to everybody who registered, along with the video, so you could view this again. And of course, there'll be a few other links and things like that. So, you know, for CAD files where you can purchase on the e-store and other places like that. If you do have any questions, feel free to reach out to DME's Mechanical Engineering Department, which is DME_mech, MECH_ENG at DME.net. So DME mech-eng at DME.net, and that's also written in the chat right now. So if there are any...
Just to finish these 5 minutes, then when also talking about die casting, for example, this is a product that we have that it's not used in the plastic mold making. This is a cam slide with an integrated piston. This is used for die casting, for example. Okay. So I would strongly recommend, if there is any assistant that is working more in die casting, that we have products that we have developed for the die casting, and for example, this is one of them. Okay. So we have with 4 guides, we have with 3 guides, for example. We know that in plastic mold making, what we do is our cam slide by ourselves. We put the sliders on the lateral side, and then we move it with a pin or a hydraulic cylinder. So in die casting, as said, to be more robust, it is we build the cylinder into the slider, and this is much more robust and stronger to work in this kind of environments. But maybe this can be another webinar that we can do regards to only die casting, because I can say that 60% of our turnover in AHP is die casting. Okay, and strangely or not, now the die casters are much more active than the plastic mold making industry. We have several projects. For example, I can tell you one that now we are having with Tesla in Berlin, in the Gigafactory that they have in Berlin. So more and more die casting is being used for cars, bigger parts, stronger parts, and that's where our cylinders, for example, our Giga cylinders also come in. So we are also developing bigger size cylinders for this, but maybe this can be a topic for another webinar.
Absolutely, we would love to have you come back for another one of our webinars from here.
Thank you. Without technical problems.
Without the technical problems, we will get that figured out, sorted out right away. Absolutely. Other than that, I believe we hit time at noon, unless there's any other questions. If you do have questions afterwards, please feel free to email DME back, and we'll be happy to answer them. Other than that, I want to thank everyone for attending and bearing with us with our technical difficulties. I also want to thank Ricardo for joining us and telling us all about the advantages of block cylinders with AHP Merkle. And other than that, thank you everyone for attending, and we will see you next month for our next webinar. Thank you, everyone.
Thank you very much. Thank you. Bye.
Bye-bye.
Have a good day.